June 7th, 1940. Inside Chrysler's Highland Park headquarters, the phone rang. It was a call that would last just 7 minutes, but it would change the course of modern warfare forever. On the line was William Knudsen, President Franklin Roosevelt's newly appointed Commissioner of Industrial Production. His question was short, strange, and almost absurd. Can Chrysler build tanks? K.T. Keller, Chrysler's CEO, paused before answering. I don't know, he said honestly. I've never even seen one. At that moment, the United States Army had just 66 medium tanks in service. Nazi Germany had over 3,000 sweeping across Europe in a storm of steel. America's entire armored force could have been wiped out before lunch on any given day of the Blitzkrieg. But what Knudsen and Keller didn't realize was that this single phone call would ignite one of the most extraordinary industrial transformations in history. In just 9 months, Chrysler would achieve what no military arsenal had ever done before, turning tanks, once hand-built by craftsmen, into mass-produced machines rolling off assembly lines like cars. The challenge began with a brutal truth. In 1940, the United States ranked 19th in the world in military power, behind Portugal. The Army still relied more on horses than tanks. The Ordnance Department, stuck in World War I methods, built tanks like sculptures, one at a time by hand, each slightly different from the last. Rock Island Arsenal, the Army's main tank plant, produced just 3 tanks per month. At that rate, the 1,000 tanks the Army wanted would take over 2 centuries to complete. So Keller called in his top engineers, B.E. Hutchinson, Frank Zeder, and Owen Skelton. The Army wanted 1,000 tanks in less than 18 months. Starting from zero, no blueprints, no training, no precedent. It sounded impossible, but Keller's answer was decisive. We won't build tanks the Army's way, he said. We'll build them our way. The team traveled to Rock Island Arsenal to see how tanks were being made, and what they saw stunned them. Workers hand-fitted armor plates, eyeballed track tension, and custom-machined every part to compensate for sloppy tolerances. No 2 tanks were identical. Keller muttered under his breath, "This isn't manufacturing, it's sculpture." He knew instantly that the key wasn't just to build faster, it was to build differently. Mass production, not craftsmanship, was the solution, so Chrysler formed a secret tank committee, pulling in the best minds from every department. They worked around the clock at Highland Park, asking a new kind of question, not how do we build tanks faster, but how do we build them like cars? That's when Owen Skelton, Chrysler's production genius, had the insight that changed everything. An automobile, he said, is 2,000 pounds of steel, rubber, and glass. A tank is 30,000 pounds of the same thing. The only difference is what we're assembling. That logic rewired the entire problem. If a tank was just a machine, bigger, heavier, tougher, then the same principles that built cars could build tanks. They redesigned every component for precision manufacturing. Gone were the loose tolerances and hand-fitted parts. Every component would be built to exact automotive standards, so it fit perfectly without manual adjustment. It was radical, and the Army thought it was impossible. But Chrysler's team pressed on. They envisioned tanks rolling down a moving assembly line just like cars, where each worker performed a single, repeatable task. By November 1940, the Chrysler method was born. The Army hated it. They said automotive tolerances were too weak for combat, welded armor was dangerous, and the idea of producing 10 tanks a day was pure fantasy. Keller shot back, "You need 1,000 tanks in 18 months. Can anyone else deliver them?" Silence answered. Chrysler got the contract. Construction began on a new facility, unlike anything the world had ever seen, the Detroit Arsenal Tank Plant. Designed by the legendary Albert Kahn, the 71-year-old architect behind Ford's River Rouge complex, it was a cathedral of industry, an entire city dedicated to one purpose. The arsenal would be more than a factory. It would be a machine that built machines. Kahn's design stretched across 1.25 million square feet, with bomb-resistant roofing, reinforced concrete walls, and an assembly line nearly a quarter-mile long. Tanks would move through a sunken trench so workers could reach every side with ease. Raw materials flowed in one direction, from raw steel at one end to completed tanks at the other. Ground broke in September 1940. The deadline, the first tank had to roll out by April 1941. But by February, the building was still unfinished. No heat, missing walls, bare concrete. Keller made a bold decision. "We'll build tanks inside an unfinished building," he said. Workers wore heavy coats as they worked in freezing air, their breath visible in the cold. A steam locomotive was brought inside the factory just to provide heat. It was insane, and it worked. Meanwhile, Chrysler's engineers solved one impossible problem after another. The tank's transmission, which took 40 hours to assemble by hand, was redesigned to take just 4. Suspension units were standardized and pre-assembled, cutting installation time from days to minutes. Welded armor replaced rivets, eliminating weak points. The Army resisted until Chrysler proved that their welded seams were actually stronger under gunfire than riveted joints. Then came the engine problem. The M2A1 tank's aircraft engine was in short supply, so engineer Harry Wilson proposed something outrageous: combine 5 car engines into one. The result was the Chrysler A57 multibank, 30 cylinders of roaring, synchronized power. It looked ridiculous, but it worked beautifully. On April 24, 1941, with the factory still unfinished, Chrysler completed its first tank, the M3 Lee. It was bulky, loud, and already half obsolete, but it represented something revolutionary. The first tank built on a moving assembly line. Production soared. By July, Chrysler was producing 2 tanks a day. By September, 4. By the following spring, they were rolling out M4 Shermans, simpler, stronger, and perfectly suited for mass production. Then came Pearl Harbor. Overnight, the 1,000 tanks that once seemed ambitious became a drop in the bucket. America was at war. Keller and his team pushed harder. By early 1942, the Detroit arsenal was producing 12 tanks per day. By summer, 18. By December, 29 per day. In that single month, Chrysler built 896 Sherman tanks, more than all of Germany's factories combined. Inside the plant, efficiency ruled everything. Tanks advanced down the line every 55 minutes. Workers competed between shifts to break production records. Welders were trained by the dozen each week. Supply chains stretched across 32 states, with hundreds of factories producing standardized parts that fit together with precision. The numbers were staggering, but what mattered most was how they were achieved. Chrysler had transformed tank building from craft to industry. What once took 500 man-hours per tank now took 150. Quality control became data-driven. Problems were identified, solved, and improved continuously. It was a living system of innovation, American engineering in motion. By war's end, Chrysler had built over 22,000 tanks at the Detroit arsenal, nearly a quarter of all U.S. wartime tank production. While German engineers meticulously hand-built Panthers and Tigers, American Shermans rolled out faster than they could be destroyed. Yes, the Sherman wasn't the most powerful tank on the battlefield. It was outgunned and under-armored compared to the Tiger, but it was reliable, easy to repair, and most importantly, there were always more coming. In war, quantity has a quality all its own. After the war, the arsenal continued its legacy, producing Patton tanks, M60s, and components for the M1 Abrams. The site remains active today, housing Army research and logistics commands. The original factory, that cathedral of concrete, steel, and determination, is mostly gone now. But its legacy lives on in every modern assembly line and every engineer who dares to solve the impossible. The Detroit arsenal didn't just build tanks. It built a new way of thinking. It proved that engineering could outmatch tradition, that private industry could outproduce any arsenal, and that impossible was just another word for not yet. From zero experience to 22,000 tanks in 4 years. The story of the Detroit arsenal is the story of American ingenuity under pressure. A story that began with a 7-minute phone call and ended with machines that helped win a world war. Because when K.T. Keller said, "I don't know, but we'll figure it out," he wasn't just answering a question, he was defining an era.